What if I told you there are places in the universe where time stops, where light itself cannot escape, and where the laws of physics begin to break down? These are black holes, the most mysterious and terrifying objects in existence. But what really happens inside them? And could one destroy Earth? A black hole is a region in space where gravity is so strong that nothing, not even light, can escape. They form when massive stars collapse under their own gravity at the end of their life cycle. At the center lies something called a singularity, a point of infinite density. Surrounding it is the event horizon, the boundary beyond which escape is impossible. Cross that line, and there's no coming back. Black holes are born from death, specifically the death of massive stars. When a star much larger than our Sun runs out of fuel, it can no longer hold itself up against gravity. It collapses violently, triggering a supernova explosion. If the remaining core is massive enough, it compresses into a single point, forming a black hole. Not all black holes are the same. There are stellar black holes, formed from dying stars. Then there are supermassive black holes, millions or even billions of times the mass of the Sun, found at the center of galaxies. And possibly even primordial black holes, tiny ones that may have formed right after the Big Bang. What happens if you fall into a black hole? First, let's imagine approaching one. As you get closer, gravity begins to behave strangely. Time slows down relative to the outside universe. From an outside observer's perspective, you would appear to slow down and eventually freeze at the edge of the black hole. But from your perspective, time continues normally. You cross the event horizon, and at that moment, your fate is sealed. There is no turning back. As you move deeper, gravity becomes stronger and stronger, until eventually you are pulled apart by a process called spaghettification. Your body would be stretched into a long, thin stream of particles. And yes, black holes really said, "You are what you eat," and turned physics into spaghetti. One minute you're a person, the next you're stretched into cosmic noodles. Dinner time just got very intense in the universe. Anyway, this happens because gravity pulls more strongly on parts of your body that are closer to the black hole. For example, your feet would feel a stronger gravitational pull than your head if your feet were closer to the black hole. This difference creates extreme stretching forces. Eventually, you would be torn apart at the atomic level. It's one of the most violent processes in the universe. And yet, black holes don't just destroy. They also reveal something incredible about space itself. There's a common myth that black holes act like cosmic vacuum cleaners, sucking in everything around them, but that's not true. Black holes only pull things in when those objects get very close. If the Sun were replaced with a black hole of the same mass, Earth would continue orbiting normally. The only difference is we would lose sunlight. So in reality, black holes are not cosmic destroyers roaming the universe. They are simply objects with extreme gravity. One of the most fascinating effects near a black hole is time dilation. This comes from Einstein's theory of relativity. Time does not pass at the same rate everywhere in the universe. The stronger the gravity, the slower time moves. Near a black hole, this effect becomes extreme. To someone far away, you would appear to move slower and slower as you approach the event horizon. Eventually, you would seem frozen in time. This means black holes are not just objects in space. They are also objects in time. In 1974, physicist Stephen Hawking made a groundbreaking discovery. Black holes are not completely black. They emit something called Hawking radiation. This radiation is caused by quantum effects near the event horizon. Over extremely long periods of time, this radiation causes black holes to lose mass. Eventually, they could evaporate completely. But this process takes longer than the current age of the universe. For most black holes, it's effectively eternal. For a long time, black holes were only theoretical. We couldn't directly observe them. That changed in 2019 when scientists captured the first ever image of a black hole. Using a network of telescopes around the world, called the Event Horizon Telescope, they created a virtual, Earth-sized telescope. The result was a glowing ring of light surrounding darkness. This was the shadow of a black hole. It confirmed decades of predictions and gave humanity its first real glimpse into one of the universe's most mysterious objects. Can black holes kill Earth? So, should we be worried? The answer is no. There are no black holes close enough to threaten Earth. Even if one were nearby, space is incredibly vast. The chances of a black hole wandering into our solar system are extremely low. So while black holes are dangerous in theory, they are not something we need to fear in our everyday lives. One of the biggest mysteries surrounding black holes is something called the information paradox. In physics, there's a rule: information can never truly be destroyed. But black holes seem to break that rule. If something falls into a black hole, all the information about it, its structure, its history, appears to vanish forever. And if the black hole eventually evaporates through Hawking radiation, where does that information go? Is it lost? Is it encoded somehow in the radiation? Or does it escape in a way we don't yet understand? This question has puzzled scientists for decades, and solving it could revolutionize physics. Are there wormholes and other universes? Some theories suggest black holes might not be dead ends, but gateways. According to certain solutions of Einstein's equations, black holes could be connected to wormholes, bridges linking distant parts of space and time. In theory, entering a black hole might allow you to emerge somewhere else in the universe, or even in another universe entirely. But there's a problem. These wormholes would likely be incredibly unstable, collapsing before anything could pass through them. So, while the idea is fascinating, it remains purely theoretical for now. At the very center of a black hole lies the singularity, a point where density becomes infinite and our current understanding of physics completely breaks down. General relativity predicts it. Quantum mechanics cannot explain it, and that conflict is one of the biggest problems in modern science. To truly understand black holes, we may need a new theory of physics, one that unites gravity and quantum mechanics into a single framework. Scientists are working on this problem right now. New telescopes, more powerful simulations, and advanced theories are bringing us closer than ever to understanding black holes. Projects like the Event Horizon Telescope are improving, and future missions may allow us to observe black holes in even greater detail. We might one day watch matter fall in real time, or even detect the exact way black holes evaporate. The next breakthrough could completely change how we understand the universe. For thousands of years, humanity has looked up at the night sky and wondered what lies beyond. We built telescopes, we launched satellites, we crossed the boundary of our own planet, all in search of answers. The deeper we look into the universe, the more mysterious it becomes. Black holes are not just objects in space. They are boundaries. They are the edge of what we understand, and the beginning of what we don't. Inside them, time and space no longer behave the way we expect. The rules break. The equations fail. Somewhere out there, a star has just collapsed. A new black hole has been born, silently bending space around it. No sound, no warning, just gravity, doing what it has always done. And maybe that's what makes black holes so fascinating. Not just their power, not just their danger, but what they represent. That the universe is not simple, it is not predictable, and it is far from fully understood. Every time we think we figured everything out, the universe shows us something like this. Something impossible. Something that forces us to rethink everything we thought we knew. And maybe that's the point. Because black holes don't just pull in matter. They pull in questions. Questions about time. Questions about space. Questions about reality itself. What happens beyond the event horizon? Does information truly disappear? Are black holes gateways? Or just endings? Right now, we don't have all the answers. With every new discovery, every new image, every new theory, we take one step further into the unknown. And maybe one day, we'll finally understand what lies inside a black hole. But until then, they remain out there, silent, invisible, unimaginably powerful, waiting.